Hey, okay, hello, our dear subscribers. To others, if you haven't subscribed, please do subscribe. So today we'll be doing introduction to probability. Yeah, I know, guys, I promised this video and I couldn't deliver it. But okay, it is here now. So you'll realize that today's video is very different from the others because I won't be doing all the lecture slides. I'll be doing the formulas and maybe some questions, but I won't do everything in your slides, right? So without wasting more time, let's get into it. Oh, and before I start, please make sure that you know all the definitions that were given in your slides. Just go through them, make sure you know them, you understand them. And yeah, so number one is just to show you that our probabilities will be between 0 and 1. We cannot have a negative probability and we cannot have a probability that is greater than 1. So here they are showing you that a probability of a certain event equals to 1. So probability of a null event is 0. So now let's go and look at the, what do they call it, the addition rule. So the addition rule says that the probability of A union B equals to probability of A plus the probability of B minus the probability of A intersect B, right? And for 3 events, that is the formula that we use on the screen. So under the addition rule, this is the addition rule, the standard addition rule, guys. So if they tell us that our events are mutually exclusive, we know that mutually exclusive events, right, we know that the intersection of A and B is a null event, is null, right? So the probability of a null event equals to 0. So if our events are mutually exclusive, we know that in our addition rule, this term will go to 0. That's why for mutually exclusive events, we have probability of A union B equals to probability of A and plus probability of B. Excuse me for that. So okay, this shows when we have n events or a number of events which are mutually exclusive. This is the formula that you will apply. So let's go to complementary events. So for complementary events, we saw that under set theories, under the video, under set theories, that A complement equals to 1 minus event A, right? So in probability, it is still the same thing, that the probability of A complement equals to 1 minus the probability of A, right? So moving on. So the probability of A given that B has occurred is equals to the probability of A intersect B complement. You can see the shaded area here, right? So which is also equals to the probability of A minus the probability of A intersect B. So look at this diagram and you'll understand where these two formulas come from. So we move and let's talk about the multiplication theorem. So the multiplication theorem, this is the standard multiplication theorem. So we know that the probability of A intersect B equals to the probability of A times the probability of B given that A has occurred, right? So for independent events, when they say these two events are independent, we know that the probability of B given that A has occurred will be the probability of B, right? So for independent events, we know that the probability of A intersect B equals to the probability of A multiplied by the probability of B. If they did not tell you that the events are independent, please use this formula. So moving on. Conditional probability. So okay, this is for the probability of B given that A has occurred, we can see that it is equals to the probability of A intersect B divided by the probability of A. And the probability of A given that B has occurred equals to the probability of B intersect A divided by the probability of B. So, okay, the difference between these two probabilities is that, please note that your denominator, every time your denominator will be the probability of this event here, right? You can see that. So you know or remember that A intersect B equals to B intersect A, right? And therefore it means that the probability of this will be equals to the probability of that. So you can see here that the probability of A intersect B, it's either this or that, right? And these two come from here. Remember here we said that the probability of this equals to this term here, and the probability of this equals to this term here. So we note or we acknowledge that these two terms, the numerators of these two equations are equal, right? So when they are equal, we know that the probability of A intersect B will be the probability of B given that A has occurred times the probability of A. And this probability will be this from the formula. And given that these two are equal, we can conclude that this equals to either this or that, right? So this is what we have at the end. I'm sure this is the formula they give you in the lecture slides, if I'm not lying. So using that, when we know that, okay, the probability of B given that A has occurred equals to the probability of A multiplied by the probability of B given A equals to A, or equals to the probability of B times the probability of A given that B has occurred divided by the probability of A. So most of the time, the formula that you are going to use will be this one, because you can see that this one is the unknown that you are looking for, right? So obviously you can't use this formula because the unknown is here, so you use this one. Here it was just to show you that these are the same. And if you were told to solve for the probability of A given B, you know that your denominator will change into probability of B, right? So please do check the Bayes theorem and the law of totality, because you'll see when I'm doing an example later that we'll obtain the probability of A using the law of totality. So please check out those two. For circuits, these are the two equations that we are going to use, or that we are going to consider. Please do check out page 40 in your textbook and do the examples that are given in the textbook. Then I'll be sure to do an example. I'll be sure to do an example later or in the other videos. So so the probability of an event when you are not given probabilities of the events. For example, if you are not given the probability of A, B, or C, and they require you to find the probability, what you're going to do is that you will find n of the event, and then you will find your sample space, and your probability will be the NE over the sample space, right? So having said all of that, this is a summary of what you've done in introduction to probability. So I'll be sure to do some questions so that you can see how we apply the different equations I've shown you. And yeah. So I wanted to do quiz 6, but this is quiz 6D from 2019. So guys, I'll post all the quizzes that I have on Telegram. You know our Telegram, whatever. So if you don't, check in the description box down below. So I'm thinking of not doing the quizzes. I don't know. Okay, so this was the first question. Yeah. So it was like, a computer password is to be created by forming a sequence of all the letters in the word refrigerators. What is the probability that a password will be such that all identical letters come one after the other? So, okay, this is the answer that you'll get, but don't worry about the answer. So I believe that now that you've done counting methods, you can find, or you can get NE, right, from counting methods. I believe you can find the sample space. I believe that you can find the event, right, from all the videos you've done, all the practice you've done under counting method. So I might not solve the questions, but rather I might show you I don't know what I'm going to do, but anyway. Okay, so NE, guys, NE, you know, you will be solving so NE, you will be solving for okay, so NE is the answer that you will get when you solve for the condition. So remember, under counting methods, you were given a scenario and then conditions to meet, and then you'll solve that. So NE you'll just do it the way you know how you do your counting methods. So the sample space, we know that it's all the possible outcomes we can get. So for the sample space, what you are going to do is that you are going to solve the question without any conditions, without taking into so for the sample space, you are going to solve the thing without regarding any conditions, right? So you will solve the thing. So as we can see, we have refrigerators, and refrigerators has identical letters. So remember, from the intro, we were told that permutations where some set of objects are identical was n factorial divided by n1 factorial times whatever. So for the sample space, you are calculating all the possible outcomes you can have, right? And then your NE, you are solving for the condition, and then your probability will be your NE divided by the sample space. So the sample spaces, you will find them from the equations that we did in the intro. You know, if you have different things, when you are solving for your sample space, it will be n factorial, right? And then you will see what conditions you are given, then you will solve for your NE, right? So it's better if you know those equations, because you will need them in this chapter. So moving on. So we know that the sample space for n unique things will be n factorial, and then I've showed you this one. So for sharing the sample space, so now I'm giving you the sample space, guys. So the sample space for sharing identical things, you'll use the sharing formula. The sample space for sharing for sharing different things of that thing, the sample space for partitioning will be k to the n, right? And like all the formulas I used to explain the different concepts will be your sample spaces when we get into probability. And then to obtain your NE, you will solve for the condition, and then you will obtain your probability by saying NE divided by the sample space. That's everything, I think. That's everything. Yeah, so okay, those are some of the questions you can get. So make sure you know the sample spaces. I hope it's not a problem that I didn't do the examples, but I hope you understand. So this is an example from 2019's lecture slide. It was the last slide under the introduction to probability lecture slide. So the question said, 3 machines A, B, C produce respectively 50%, 30%, and 20% of the total number of what items of a factory. The percentages of defective output of the machines are 3%, 4%, and 5% respectively. So the first question was, what is the probability that a randomly selected item from the factories produced is deflective? So we want P deflective. We want P deflective, right? So we are going to use the law of totality. So we can see that we have different machines that are producing these items. So to find the probability, we need to sum up all the probabilities using law of totality, right? I hope you know the law of probability of totality. Please check it out if you haven't. So from the law, they gave us this formula. So to find P of deflective, we are going to say it is equals to the probability of the deflective items given that A, right? Okay, so we will say PD given A, so the probability that the item is deflective and it's from machine A, right? And then we'll sum up until all the conditions are met. So the probabilities were already given, so we just had to substitute and get the answer, right? The second question says, suppose a randomly selected item is found to be defective. What is the probability that the item was produced by machine A? So you can see that, okay, they found an item, they selected an item and it was defective. So now they want to know that what is the probability that the item was produced by machine A. So we are looking for the probability that the item was produced by machine A given that it is defective. So that is a conditional probability, right? So they are telling you that, okay, we selected an item or we found this, and so after finding this, find the probability of something else given that you know that probability. So you know that it is a conditional probability. So from what we've discussed earlier in this video, you know this equation. So I told you that the total probability, or your denominator, you will solve it using what? The law of totality. Okay, likely in this one, the first question was to find PD. So you've got that. What you are going to do is substitute and get your answer. Even if there wasn't a question that said find PD, you know that after substituting, you will do this step here and then solve for your thingy, right? Okay, so we have a question here. It says a manufacturer claims that its drug test fails to detect steroid use. That is, it shows negative for an athlete who uses steroids 4% of the time. Further, 92% of all steroid-free athletes also test negative. 10% of the rugby team members use steroids. Right. So, there is a drug test and they are testing rugby team members. So, it is advisable that you draw a tree diagram for problems like this. So obviously the drug test will be used like on people. That's why we started with this. A lot of students ask how will I know which probabilities to start with? Okay, firstly, it is a drug test and we are going to test people, right? And of the people that we are going to test, we have people who are using steroids and who are not using steroids. So we can start with that. So they told us that 10% of the rugby team members use steroids. So the probability of people who are using steroids is 10%. That's why we have PS 10%. The S stands for steroids. So if 10% of the team uses steroids, it means that the rest are steroid free. They are not using steroids. So we said 100% minus 10%, or you can write these in decimal form. Doesn't matter. So they also told us that the drug test fails to detect steroids use. That is, it shows negative for an athlete who uses steroids 4% of the time. So the probability that the test shows negative when an athlete uses steroids is 4%. If it's 4%, we know that okay, it means the probability that it will show positive for a member who uses steroids, it is going to be 100 minus 4, which is 96%. They also told us that 92% of all steroid-free athletes also test negative. So 92% of steroid-free athlete tested negative, né? So it is the probability of N given that steroid-free. And then we can find the probability of P given that steroid-free. So the first question was, what is the probability that if the test is administered to a randomly selected player, the player will test positive? So simply it means that we should find the probability of positive, right? Probability that the player will be positive. So using the law of totality, we know this formula, guys. So you are going to substitute. You are going to take your numbers from the tree diagram. We are going to take this here times this plus this here times this to get the probability of P, right? So this is our answer. B says a player on the rugby team has just tested negative. Assuming the manufacturer's claim is true, what is the probability that he uses steroids? So we want now we know that this is conditional probability, where now we are solving for the probability that the player uses steroids given that he tested negative, right? So we know using the formulas that we saw on the other slides. Yeah, and for this one you can obtain it using the law of totality, or if you're a lazy student, you know that you found P positive. Now you know that P negative will be 1 minus P positive, so you can just say 1 minus this probability and just substitute it here to get your answer. So that is how you do questions like this. You can see law of totality, conditional probability based theorem. Yeah, so I think we've covered all the formulas here, or I didn't do an example under multiplication theorem. And these formulas you can also use. You will use them if you are given the circuit problem, or you are given a Venn diagram and you have to find the probability there. Yeah, when you're solving axioms. I'll find a question where I'm showing you how to use multiplication rule, and let's see. So sometimes you'll be given a Venn diagram like this one here, and you'll be given questions. So this was under quiz 8A 2019. So I'll post the quizzes as I said before. I can see some parts are not clear. Okay, it's because I'm using a pencil. I don't have a pen, guys, so I'm sorry for that. Just bear with me, right? So the question was, suppose A, B, and C are independent events, right? And what else did they say? Such that probability of A equals to PA, probability of B equals to PB. That's B, sorry. So sorry about that. So they were like, show that the probability of A complement intersect B union C complement in brackets complement equals to that, right? So they gave you this to show that this equals to that. They also gave you a diagram showing you this region, right? And so what you have to do is if you know the De Morgan's laws, I hope you know them. I hope and pray that you know them. So you know that you will change this part to this, right? And you end up having this. Guys, you need to work on your De Morgan's law. Make sure you know the laws. So now you have this, right? You can see that it is the probability. It is this. You can see that there's the probability of A complement times B. It is the probability of A complement intersect B complement intersect C. I hope you can, right? So you are able to describe the notations of the shaded part now after doing the set theory video, right? So if you can say now, okay, it is going to be the probability of C minus the probability of A intersect C, which is this part, minus the probability of B intersect C, right? But if you can look closely, when we minus A intersect C and B intersect C, this part, the smaller part where A, B, and C intersect, you can see that we are removing it twice. So we also say plus A intersect B intersect C. So from here you can use the formulas I gave you earlier. These formulas, right, you can use the formulas. So they also told you that the ABC are independent events. So you know that this part will be the probability of A times the probability of C. If they were not independent, you know what the expression will be, right? Then you solve and show that that equals to this. Or the other person can say it is the probability of C, right, minus the probability of A intersect C, which is this part. If you don't want to repeat this part and say minus the probability of this one now, the probability of A complement intersect B intersect C, and then you are going to solve and you will get the same answer. So when you are given a Venn diagram, it depends on how you interpret it. So yeah, just make sure you are able to do that. And the last question was, are the two events A and B union C complement all to the power of complement? The complement of B union C complement, are they independent? So for you to know whether they are independent or not, you need to prove that this part, this equals to probability of A times probability of that. Because remember, if you're given if from this for independent events, probability of A intersect B equals to the probability of A times the probability of B. So you will solve this. Obviously they gave you a diagram showing this part, so you will solve for this using the diagram. Then you will also solve for this part using PA, PB, and PC, and then you'll compare the two answers and see if they are equal. If these two answers are equal, then you know that they are independent. If they are not, you will say no, they are not independent. I couldn't do that one because my pencil is finished now, guys. So my pencil is finished. I think that's all for today. I'll see you when I'm doing other questions, or when I'm doing 2019's test 1 question paper. I'll just go through it as part of revision, and to look for I'll also look for an example where we are using this equation here, right? So that's all for today. Thank you very much. Do subscribe, like, and comment if you have any questions. Bye.